All right, this is going to be the last one. It's going to take us approximately 6 minutes. Ishmael and Mustafa, thank you for being excited. Excellent. You brought excitement to the class. Yusef, have you brought your excitement to the class? Excellent. Matt, you are on the edge of your seat. When I think of excitement, I think of Matt. Excellent. Thank you, Matt, for bringing the excitement to class. Joe, I'm not quite sure what you brought to class, but it is exciting. Okay, excellent. Now, the solution process, the solvation process, not salvation process, the solvation process. Solvation process. Okay? To form a solution. Now, listen carefully. I'm going to just rock through this. Elements and compounds, gold, silver, tungsten, hydrogen, sodium, lithium, technetium, right? Technetium. Those are individual elements. Water, H2O. I can have a pure substance. A pure substance is either a compound, sodium chloride, water, or an element, gold, silver, platinum, hydrogen, oxygen, fluorine, chlorine, bromine, right? So that's what a pure substance is. Now, a pure substance could be defined as a homogeneous collection of the same thing. All gold. That's homogeneous. Yes? Yes or no? Yeah. All hydrogen, homogeneous. But you can use the word homogeneous when you're talking about a combination. If I take these two things, can I create a homogeneous combination of them? No. In other words, this is a phase, right? Something came up on the screen, okay? Yusef, my videographer, it says low battery. That's okay, I'll be off in a minute, okay? So this is a phase, yes? Do you see that? In other words, what's a phase? A phase is a single set of physical boundaries. I can see this. It's spray for the board, correct? There's a cup, okay? I just had this horn removed. Didn't look good, okay? It was a stump, and I just said, you gotta get rid of the stump. So now I look like this, okay? Otherwise it was a stump, and I had this horn, okay? It's true, okay? Now, but if I can take water and mud, dirt, will that form an individual set of physical boundaries, or can I still see the dirt, the sand, and the water after I try to dissolve it? No, I can't. Okay, so that's not going to work. How about if I take sugar and water and dissolve the sugar so I can't see the water? I can't see the sugar. I can only see water. Is that a solution? Yes. Yes. When I have a solution is, listen carefully. Listen carefully. A solution is a complete and absolute combination of two or more phases resulting in an individual phase, such as sugar and water. I stir it around, I only see the water. I only see one set of physical boundaries. Do you understand that? That's a solution. A solution is a homogeneous combination of two or more substances creating a single set of physical boundaries we call a phase. Correct? In terms of pure material, is a solution of sugar and water, is that homogeneous? In terms of pure substances, purity, is it homogeneous? No, it's not pure. It is not a homogeneous. But in terms of being a combination of two or more substances resulting in one phase, is it homogeneous? Yes. Yes, it is. Do you see the difference? Yes. Now, how does this water work? How does it create this single set of physical boundaries? How does it do it? Well, I have these plus minuses, these ions. I have these ions at the bottom of a beaker, right? right? The water will come in and take them. So the water's going to line up like this, right? Mm-hmm. And it's going to simply take them. It's going to take them and latch onto them and bring them into solution. So the water, the polar nature of water, will take the individual ions and bring it into solution, lining up charges. The negative hydrogen, the partially negative hydrogen side, will that line up with a sodium or a chlorine? That partially positive hydrogen in water. This partially positive, it's going to line up with the chlorine, right? Who said sodium? This is partially negative. That's going to line up with, so it's the polar nature of water. If something is, if there's a solid that can't be broken down into ions, can it dissolve? Not really. Will it dissolve well? No. Will it dissolve a little bit? Oh, maybe with some dipole dispersion force something, but will it dissolve completely? No. It has to be in the it has to be broken down into ions. You all right with that? So this is the making of a solution. This is Solvation Part 1. See you on Tuesday.